Okay, welcome to the video, the first one in the series on right-angled trigonometry. And in this one, we're going to be looking at the ratios that we use in trigonometry. The first step in getting your trigonometry right is actually being able to identify the sides for a given angle. Now here we have the angle theta. Theta is just a Greek letter. It's one of those traditional things that we use in trigonometry, is a lot of the Greek stuff. So let's take a look. Now, you know from year 8 that the hypotenuse is the longest side in a right angled triangle. So let's mark that in. And we use the letter H to identify the hypotenuse. Then we've got the opposite. The opposite is the angle, is the side that is opposite to the angle. It doesn't touch it, it faces the angle. And the adjacent is the side which is between the chosen angle and the right angle. It's next to the angle, but it's not the hypotenuse. So here we have H for hypotenuse, O for opposite, and A for adjacent. How about copying these diagrams down? Identify the hypotenuse with an H, the opposite with an O, and the adjacent with an A. I'm asking you to do this because identifying these correctly is the most important thing in being able to identify which ratios you eventually use. So here are our diagrams. What I'd like you to do is pause the video and then start the video again and check your answers. So here are our hypotenuses, our opposites, and adjacents. The ratios. There are 3 ratios that you need to know. Sine, abbreviated SIN, cosine, abbreviated COS or cos, and, last but by no means least, tangent or tan. So it's sine, cos and tan, SIN, COS, TAN. The sine ratio. For any given diagram, once you've identified the angle, and it's important to identify the angle, and then for that particular angle, identify the H is always going to be in the same spot, but the O and the A. Sine of the angle, so sine theta, is the ratio of the opposite to the hypotenuse. Examples. Here we have a triangle. We're putting 13 centimetres on one side, 12 centimetres on the opposite, so we have a hypotenuse of 12. No, we don't. We have a hypotenuse of 13 and an opposite of 12. So sine of our theta is opposite over hypotenuse, which is 12 over 13. That fraction doesn't simplify any, so you just leave it as 12 over 13. Here we have another triangle. We have 20 metres and 32 metres marked in on them. The O is the 20 metres, the 32 metres is the H. So sine of theta is 20 over 32. And in this case, we can simplify that as 5/8. The cosine ratio. The cosine ratio is defined as the ratio of the adjacent to the hypotenuse, so A over H. Let's look at some examples. Here we have a triangle, hypotenuse of 13, an adjacent of 5, so cos of theta is A over H, which is 5 over 13. Here we have another triangle. We have 7 metres along the bottom. We have a hypotenuse of 32, so our adjacent is 7 metres, our hypotenuse is 32, so cos of the angle is A over H, which is 7 over 32. Tangent ratio. Here's our triangle. Tan of the angle is defined as the ratio of the opposite over the adjacent. So let's look at some examples. Here's our triangle. Our opposite is 12 centimetres. Our adjacent is 5 centimetres. So tan of the angle is opposite over adjacent, which is 12 over 5. And you can make that into a decimal as 2.4, but whatever you want. Another example. You have an opposite of 19 metres, an adjacent of 5 metres. So tan of the angle is opposite over adjacent, 19 over 5. Done. Remembering the ratios. And with working with trigonometry, the most important thing is to get your ratio right. Once you've got the ratio correct, you're halfway to solving whatever problems we're going to throw at you. So here's our three ratios highlighted. So sine is opposite over hypotenuse, so you can remember that as so. Cos is adjacent over hypotenuse, so that's car. Tan is opposite over adjacent, so that's toa. So that's so car toa. Remembering so car toa will help you get it right. So sine of the angle is opposite over hypotenuse. Cos of the angle is adjacent over hypotenuse. Tan of the angle is opposite over adjacent. Now I know at this stage that's saying, well, yeah, so what? Well, a bit later on in the next videos, we'll actually show you how to use this to solve problems in trigonometry. It's an important thing to remember. Tan is the only ratio that can be greater than 1. And if you think about it, it's logical because both sine and cos have got the hypotenuse on the bottom, and that's the biggest side in the triangle. So of course it's going to be less than or equal to 1. You got some more to know too. Let's look at sine theta divided by cos theta. Well, that's O over H divided by A over H. Now we're working with fractions. So our rule for fractions is when you're dividing by fractions, you leave the first one alone, change the divide to a times, and flip the second fraction upside down. So when we do this, we get sine theta divided by cos theta is O over H times H over A. Now we've got an H on the bottom and an H on the top. So H divided by H is 1, so we can cancel those out. So sine theta divided by cos theta is O over A. Now if you think back to the trig ratios that we've just defined, O over A is defined as being tan. So tan theta can also be thought of as being sine theta divided by cos theta. So here we are. That's the ratios. Good luck on going to the book and working to identify the ratios correctly.